Okay, we're going to do two examples here dealing with logarithms and just evaluating. So we're going to use these properties in the previous video to work with this. A couple things that I notice here, and that's what you have to start to identify, is I got a base 5 and a 125 here. I'm adding these two logarithms and I'm saying evaluate. So when I say evaluate, I'm going to get a number. That's going to be my solution. So that kind of tells me I'm not rewriting, I'm not combining it as one logarithm, I'm not simplifying, I'm going to get a number. And then I notice, based on some of these properties, log base 3 of 3, because I have these same bases, what we saw in the previous property is these guys are going to cancel out. We'll talk about why that happens, and then eventually you're going to recognize that it's a trick. We just cancel it out. I also have 5 and 125. I know I can write this as a base 5. So here's what we're going to do. We're going to start with this left piece, and we're going to go ahead and start working with that. And so I'm going to rewrite just this piece in exponential form over to the right-hand side. So log base 3 of 3 to the 5th power is equal to some number. So then if I rewrite it in exponential form, 3 to the x is equal to 3 to the 5, 3 to the 5th power. So what does x have to equal? X has to equal 5. So this whole term is equal to x, and we've just found that x is equal to 5. So if I rewrite it in exponential form, I'm going to see this. So the trick is a couple things. We have this power property, which tells us I could take this 5, and then it's multiplied to log base 3 of 3. Well, because they have the same, the base and the number are the same, this cancels out. I'm left with 5. So let's rewrite log base 5 of 125. I know I can rewrite 125 as 5 cubed. So the trick is, I see this piece, the base and the number are the same. What's going to be left over is the exponent. Why is it left over? We saw right in here that that's why the exponent is just what's going to be left over. So a couple different ways to look at this. These can be very quick problems if you get the pattern down. Let's move on to our next. In this next example, we're evaluating the expression. So evaluate. So because we're evaluating, I'm going to get a number. So I'm going to look at these two pieces, and now I have, instead of a logarithm, I have an exponential function that has a log in the exponent. Let's do the same thing. Let's convert it to a logarithm. What does this equal, right? Okay, well, log base 2 of x is equal to log base 2 of 3. So based on looking at this statement, this is a equality statement, x has to equal 3. So that means this whole thing is 3. Okay? Well, now let's look at the pattern. 2 raised to the log base 2. So because these guys are the same, we can go through here, cancel it out. All that's left over is 3. It's no longer in the exponent, it's dropped down. I can now kind of go through this. I'm going to rewrite this as base 6. So log base 6 of 136. I know 36 is the same as 6 squared. And I want the 6 to be in the numerator. So when I have something in the denominator, I write it as reciprocal and change the exponent to a negative value. These guys cancel out, right, because of the 6 and the 6, and I have 3 minus a negative 2, and that's going to equal 5. So that's how we can evaluate logarithms, get a specific number, by working with these different properties of logs that we've talked about. This is how we use that one-to-one property that was in one of the previous videos.